So welcome to page 29 and 30 of the solutions packet. This is much more important than the last video. It's a very hot research topic, right? It's called parts per million. Again, this is another way to measure concentration. The formula is on your reference table right above the molarity formula. So again, molarity measures concentrations of small solutions, like the concentration of Kool-Aid in water, the concentration of acid or base in the laboratory, the concentration of copper, Roman numeral 2 sulfate solution in the laboratory. Parts per million measures concentrations of small amounts of something in a large body of water, right? Like the amount of mercury in the Hudson River, the amount of calcium in a shark's blood, okay? So stuff like that. The amount of chlorine in a swimming pool. Okay, so parts per million. So parts per million. Now it's the same thing, it's a percentage, but instead of multiplying by 100, you multiply by 1 million. Okay? There's also in real life they have parts per billion and stuff like that too, but you don't have to know that. Alright, so let's get the formula off table T for top page 29. So again, it's parts per million. We can write the abbreviation, which is ppm, all lowercase, equals, it's mass of solute over mass of solution times 1 million. Okay, so that's a 1 with 6 zeros after it. It's on the reference tables with the formula. Okay, so it's just the same thing we just did, but instead of multiplying by 100, you're multiplying by 1 million. Okay, so again, just like the last one, the only thing they could ask you to solve for possibly is parts per million or mass of solute. Okay, so I'm only going to do numbers 1, 2 on top of the page, then I'm going to do 5 and 6, the first two multiple choice questions. Alright, and then the rest you're going to do on your own, and I'm just going to give you the answers. Okay, but this is a very common Regents topic, just like molarity math problems. Okay, percent mass, percent volume, you don't have to worry about it too much. It doesn't show up that much. All right. So here we go. Number 1 it says approximately 0.0043 grams of oxygen can be dissolved in 100 milliliters of water at 20 degrees Celsius. Express this in terms of parts per million. All right, notice they give you grams and milliliters. Remember what I said? 1 gram of water is 1 milliliter of water. Right? 1 gram equals 1 milliliter. Okay, so we just convert that 100 milliliters to 100 grams. Okay, so our small numbers always are solute, and for parts per million, it's going to be very small numbers, like here, 0.0043. That's our mass of solute. Again, we're solving for ppm. Okay, now for mass of solution, remember you have to add the two numbers. For parts per million, if you don't add the two numbers, you're probably still going to get roughly the same answer, but for good practice, we should still add the two numbers together. So you add 100 and 0.0043, you get 100 and 0.0043, like that. Then you just times it by a million. To do your math, you calculate 0.0043 divided by 100.0043 times 1 million, and you should get 43 ppms, 43 parts per million. Okay? All right, and number 2 I'm going to do it because it gives you that liter again. Remember, liters, you have to convert it into milliliters. All right, and we're solving for mass of solute. Number 2, a swimming pool reading reports that chlorine is present at 60 parts per million. How many grams of chlorine are present per liter of pool water? All right, so we have to know here is 1 liter is how many milliliters or how many grams? 1 liter is 1,000 milliliters, which is 1,000 grams. 1 milliliter equals 1 gram. So 1 liter of water is 1,000 milliliters, which is 1,000 grams. Okay, and they give you the parts per million, which is 60. You're solving for mass of solute. And then there's your times a million. All right, so we start out these like we just did the last two number 3s for mass of percent by mass, percent by volume. So instead of dividing by 100 on both sides, we're going to divide by a million on both sides. Divide by a million here, the millions cancel out. Divide by a million here. So you're basically moving the decimal point 6 places to the left. So you're going to get 0.00060 equals x over 1,000 next, just cross multiply. 0.00060 times 1,000, right? Which is basically moving the decimal point 3 places back over to the right, and you get your answer of 0.06 for number 3. Okay? All right, so let's do numbers 5 and 6 multiple choice. These are Regents questions now. And they should be a little bit easier than the ones I just did. Okay, so let me erase this. It'll be one of each again. One solving for parts per million, one solving for mass of the soluble. Those are only 2 things they will ask you to solve for. Okay, number 5. What is the concentration of O2 in parts per million in a solution? If in a solution that contains 0.008 gram of O2 gas dissolved in 1,000 grams of H2O liquid. Okay, so our mass of solute for number 5, again, this is number 5 on the bottom. 0.008 grams of solute, and you got 1,000 grams of water, and you're supposed to really add that number to it, so it's like 1,000.008 times 5 million. Okay. And you should get an answer of 8. So we get 8 parts per million for our answer. Divide and multiply by million, so that is choice number 2. Okay, now let's do one word solve mass of solute, number 6. Number 6 says, was the total mass of solute in 1,000 grams of a solution having a concentration of 5 parts per million? Okay, so put it right over here. So you got 5 parts per million equals X over, give you 1,000 grams of solution, times a million. So this is just like the one I just did. You divide by a million on both sides first. That cancels out. Divide by a million here, which means move that decimal over 6 places to the left. So you get, is that right? 1, 2, 3, 4, 5, 6. Yes, so you get this number, 0.00005. Equals X over 1,000. And just cross multiply by 1,000, which is basically moving the decimal 3 places back to the right. And you should get 0.005. Right? 1, 2, 3, yep, 2 zeros after the decimal. 0.005, which is choice number 1. So now I want you to finish all of page 29, the rest of page 29, and all of page 30. Pause the video and work on those parts per million questions. Okay, so here are your answers. Number 3 is 1.4. Number 4 is 116.5. Number 7 is choice 1. Number 8 is choice 4. Moving on to page 30. Number 9 is 231.2. Number 10, your setup is 388. Write this on the board. So answer number 10 is 388 equals X over 500 times 1 million. And you have to have an answer too. The answer is 0.194, I believe it is. 0.194. Now, number 11 is a table F question. Based on table F, identify one ion that reacts with Br negative ions that in an aqueous solution to form an insoluble compound. All right, so you know near the bottom left of table F, Br minus is under the halide section. So all Br minuses, which are under halides, are soluble except for silver, lead, and mercury. So you can put, all you have to do is put 1, so don't put like 2, right? So the answers are, just copy off table F. So the answer would be Ag plus 1, Pb plus 2, or the Hg2 plus 2. Right? So any of those are acceptable. There's only 3 ions that are insoluble with bromine, the bromine ion, Br minus. Okay. All right. Number 12. All right. The answer is they ask you, would this sample of water be considered hard water based on what the reading test? The answer is no, because there's only 53.3 ppm. So the answer is no, because there's only 53.3 ppm. So when you calculate number 12, you should have got 53.3. Right, so that's to be more than 60 parts per million to be considered hard water. So if you got 53.3, which is less than 60, the answer is no, because it's only 53.3. So it's not hard water. Okay. So now number 13. Number 13, they just wanted they want the setup and the result. Right. So number 13, your setup is parts per million equals 0.0070 over 1,000.0070. So you have to add the two numbers times a million. Right. And your answer should be 7. Parts per million equals 7 for number 13. And the answer number 14 is 1.43. All right, so if you have any questions, you can email me. All right, so this concludes our parts per million video, so stay tuned for the next page.